Hi, this is Mrs. Bustamante, and this is our third video about chi-squared. We left off determining what our critical value was for this hypothetical experiment with pea plants we were doing, and we found that it was 3.84 on the chart. But what do we do with this value now, right? What does that mean? What does this critical value mean to us? Well, we use it to either support or reject that null hypothesis we wrote earlier, right? And remember, we said our null hypothesis could always be there was no statistically significant difference between the observed data and the expected data, basically like what we thought would happen did. But we said in ours that there's no statistically significant difference between the number of tall and short plants observed and the number of tall and short plants expected, which again we saw, like, even though my data didn't match exactly, it was pretty close. And so that's kind of our gut instinct, right now, that we think we will say, yeah, that's what we think is happening. So what do we do now? Well, we compare it, okay? And when we compare our chi-square value, there are basically two things we have to look at, okay? If our chi-square value is greater than or equal to our critical value that's listed in the table, we reject our null hypothesis. We say that there is a statistically significant difference between what we observed and what we expected. If our chi-squared value is less than our critical value in the table, we support our null hypothesis, or in statistical terms, we would say we fail to reject our null hypothesis. So this essentially are the two statements we use to evaluate our data. So let's go ahead and look at what we got. Well, our chi-squared value was 3.333. And the critical value we're going to compare it to is 3.84. So when we look at that, 3.333 is less than 3.84. If it's less than 3.84, we say that we support our null hypothesis, or we fail to reject our null hypothesis. Now, something important here, we're not going to prove anything. I like to say we're not that good, right? So we can either support or refute, or support or reject our hypothesis or our null hypothesis, but we really can't prove anything at this point. We haven't done enough data. We don't have enough information, right? So what could we say? What would be a statement we could write about our data? We would say that there is no statistical significant difference between the observed and expected, kind of our generic statement we talked about, right? Or we could say there is no significant statistical difference between tall and short plants observed and tall and short plants expected. And that would be a way for me to evaluate my data. Now, what if earlier I had rejected our null hypothesis? Well, if we reject our null hypothesis, we have to go back and do some more thinking, I guess, right? If we reject our null hypothesis, we have to come up with a new hypothesis, because there was some statistical difference that we kind of didn't anticipate happening, right? So the idea that you reject would make sense because the values are even further off, or the numbers are more different than you would have expected, right? So you want to go back and you want to think more about what's happening and evaluate your data further, maybe even come up with a new hypothesis that makes more sense.